Okay, so example number 3 looks like it's going to be exactly like example 2 because I only have the x squared term and the constant term. But if you look over here, this equation is not set equal to 0, so it's not ready for the quadratic formula just yet. It has to be equal to 0. Plus, here's my x term, so I have a b value. It just needs to be on the same side as the a and the c. So I've got to do some rearranging. So I've got to add 11x, and since it is my b term, I'm going to put it where the b term should go, in between those. So this is actually 9x squared plus 11x minus 16 equals 0. Now it's equal to 0. This time I do have a, b, and c value. The b value was just on the wrong side. I had to fix it. So now we can plug it in. So negative b plus or minus b squared minus 4ac over 2a. All right, so just plug those in where they go. Type it in the calculator. Now on this one, I could leave out the parentheses on the negative 11, so I think I'll do that. The before the parentheses, or the before the plus and minus, that parenthesis is not totally necessary, but just for the kind of template format, we use it anyway. Just be careful with it. I forgot my plus sign. There we go. So now we're going to do 11 squared minus 4 times 9 times negative 16 over 2 times 9. All right, so this equation would not be factorable, I can tell by this answer, because it is an irrational number. It doesn't end, it doesn't repeat. So this would not be a factorable problem. So back when we were doing solving equations by factoring, we couldn't do this problem. It would not be factorable. So it still has an x-intercept. It's just not a nice, neat one in terms of fraction or whole number. So let's do just a couple of decimal places will be fine because that's pretty much all you can see on a normal graph anyway. So we'll round that up to 0.86 as the first one. Get the second one, we'll change that to a minus sign. And our second one, accounting for a couple of decimal places, would be negative 2.08. Plug them in, check it on Desmos. The only note, if you plug these in where we rounded them, it would not be exactly 0. It wouldn't give you perfectly 0, but it would give you super close to 0. Just because we rounded to 2 decimal places, but there's a whole lot more than 2 decimal places in our answer.